Hello kids, Shubha Mangalam Clinical Scholars. So now we will continue with the chapter number 1 for class 8, and the subject is physics, of course, and then we have the page number also mentioned over here. It's page number 3. So in the previous video we were discussing about the types of forces. So let's start again. Force is the push or pull happening on a certain object to perform a certain task, which can change the shape or the position of the object. And following that, we have types of forces, which are of two types: the contact force and the field forces, or the forces happening at a distance. In contact force, the objects need to be in physical contact with each other, whereas in field forces, they need not be in physical contact with each other. The example for field forces or forces happening at a distance were the magnets. Yes or no? Even though they're not actually touching each other, you can feel when you bring two magnets and two opposite poles together, you will see that they are actually pulling themselves, each other, very close to each other. Okay, that is because both the magnets have entered the magnetic field of the other one. Okay, we will deal with this definitely much deeper in much detail. Let's go on with forces acting at a distance. Okay, let's deal with this much more and in a better way. So now the first one here that we are going to discuss is magnetic force. So we know that magnets follow certain laws. There are certain laws of magnetic forces. Okay, so if I am going to place, I have two magnets with me and I place the opposite poles together. What are they going to exert? They are going to exert attraction. This means unlike poles attract each other, whereas if I have other two sets of magnets and I place the like poles together, they are going to exert a repulsion. Why do you think so? Because like poles repel. Okay, so you need to remember these two laws permanently in your head, that unlike poles attract each other and like poles repel each other. So now we have a simple experiment that needs to be done. Okay, which is like I am going to remember we have studied about magnetization also in the previous class. How do we magnetize any magnetic material or any substance? We are going to take a magnet and we are going to take the substance and we are going to rub the magnet on that substance. Okay, because of rubbing too many times, the magnetic property of the magnet is going to transfer to that particular substance, and that substance will start behaving like a new magnet now. Okay, so what do I do in this case? I will take a needle. A needle is a magnetic material. Fine. Okay, so now like a sewing needle that your mother uses to sew clothes at home. So I'm going to take a needle and I'm going to take a magnet and I am going to rub the magnet on the needle several times in a certain direction. Always in the same direction. Okay, so if I'm going from left to right, then left to right all the time. Okay, I do this for a certain period of time and then I stop, because I have magnetized my needle now. What do I mean by magnetizing a needle? This means I have transferred the magnetic properties of the magnet to the needle. Now I keep the magnet aside. Okay, I have the magnetic needle with me and this starts behaving like a magnet. Now I don't know in this needle which is the north pole and which is the south pole. So how do I identify what is the north pole and the south pole in a needle? So if this is my needle, okay, and I want to identify what is the North Pole and the South Pole, so I will take the help of a compass. Okay, the compass is going to tell me which one is the North Pole and South Pole. I place the compass near the needle, and once the compass aligns properly, I will come to know which portion or which pole of the needle is the North Pole and the South Pole. For example, the compass is showing this way, the arrow pointing upwards. This means this is the North Pole of the needle and this is the South Pole of the needle. Okay, so to better identify it, I'm going to take two small balls, one white in color, the other red in color. I'm going to tie the white ball on the north pole of the needle and I'm going to tie the red ball on the south pole of the needle. Why am I doing this? So that I identify which one is the north pole and the south pole. How did I derive that which pole is the north and which pole is the south? With the help of a magnetic compass. Okay, we have seen magnetic compass in a laboratory also. Okay, so now this is how I magnetized one needle. I'll do the same procedure with another needle. So how many needles do I have now? I have two needles with me, and I'm using the same compass again to check which pole is the north pole and south pole. I've also magnetized this needle and also placing the white ball and the red ball over here. So all in all, how many needles do I have? I have two needles. Do I know the poles? Yes, I know the poles. Did I signify them with the help of balls? Yes. The white ball represents the north pole and the red ball represents the south pole. So what am I going to do with these two needles? So I am going to take a bowl of water, okay, and I am going to place in the bowl of water the first needle, okay, the first needle where the white ball is over here and the red ball is over here. Okay, now I want to know whether the laws of magnets that I was discussing with you people are true or not. What were the two laws? That like poles repel and unlike poles attract. So what do I do in my case over here? I'm going to drop the other needle also. Okay, once I drop the other needle, I will make sure that the white ball is over here and the red ball is over here. Okay, this means in both the cases, it is the opposite poles which are facing each other. So there will be a certain amount of attraction between the needles. Do you understand? So the needles are going to attract each other along the poles. Why do they attract? Because they are unlike poles. Do you get my point? The white ball represents the north pole, the red ball represents the south pole. So north and south, when they come together, they are going to attract each other, and that is what is happening in the bowl of water. The first law is tested. Unlike poles attract, and that has been proved over here. Now what do I do for the second law to be proved? I will, you know, I will remove the second needle and I will turn it around and place it again. Okay, so that the white faces the white and the red faces the red. Okay, a clearer picture is given in a textbook also. Please try to follow it. So now so now I have the bowl of water ready for me again, and I have my case number one is done, in which I am proving that the unlike poles attract each other. Now I want to prove whether the like poles repel each other or not. I'm going to take the first needle and I'm going to drop with the north pole over here and the south pole over here. I'm going to take the second needle and drop it again in the water. This time north facing the north and south facing the south. So you will observe that the needles are actually pushing each other. Okay, so basically, they are going to push each other and try to move apart. In the first case, they were pulling each other. Now they are pushing each other. This means the needles are also exerting a certain force, because that is what is the definition of force: push or pull. Do you understand now? In case one, they were exerting a pull or an attraction between them. Now they are exerting repulsion or a push between them. Pull or push is called as force, and it is happening with the magnets over here. That is why it is called as magnetic force. Do you understand now? So the first kind of forces that we studied for field forces was magnetic force. Hope you're clear with it. The second kind of force that we are going to study is electrostatic force. Now here we are going to take a balloon, okay, and we are going to rub the balloon with a paper. Fine. Once you rub the balloon with the paper and you bring it near bits of paper, you see that they exert a certain attraction between them. Okay, what did I do over here? I'm going to take a balloon and I'm going to rub it on a paper. Once I finish rubbing, I'm going to place that rubbed balloon near some bits of paper, but I need to make sure I'm not directly touching them. Even though I'm not directly touching them, I see a certain movement in the bits of paper and they try getting attracted to the balloon. Why is this so? Because the balloon, when I was rubbing it with a paper, it acquired a certain charge, and when I dropped this particular paper rubbed balloon to the bits of paper, they acquired the opposite charge. That is why it started attracting the balloon. Okay, this you know charge is called as electrostatic charge, because once you rub the balloon with the paper, it gains some static electricity. This is the same phenomena that is happening during winter mornings. When you get up on a winter morning and you push over the blanket, you can hear some squeaky noises when you are throwing the blanket away from your body. So that is nothing but the development of a certain charge. Some charge is developed between your body and the blanket. Okay, the same thing is happening over here. One more avid example of this is when you take a comb. Okay, and when you take a comb and you rub your dry hair, you keep brushing your dry hair, and you have certain bits of paper placed on the table, and you place the comb near the bits of paper. You see that the bits of paper start getting attracted to the comb. That is because also there is a certain amount of charge present in the comb, and the bits of paper acquire the opposite charge and they start attracting each other. So now this charge that is developed because of the static electricity is called as electrostatic charge. What is static electricity over here? The certain amount of electric power generated because of rubbing two objects together. Do you understand? So the charge or the force developed because of static electricity is called as electrostatic force. And what were the examples I gave you over here? The balloon, the comb, the blanket. Okay. So now coming to the third one over here, it is the most easiest one, and it is nothing but the gravitational force. Okay, so how do you think? Why do you think that we guys are not, all of us are not jumping from one place to other? We are walking to reach our destination. That is because there is a certain force of the earth that is pulling us towards the earth. Okay, every substance or every object present on the earth is being pulled towards itself, and it is all because of gravity or the gravitational force. Okay, now remember the Newton's law? How did he discover it? He discovered while he was sitting under a tree and the apple fell down, and he wondered why was the apple falling down and not going up. Okay, now I have a marker in my hand, and if I throw it down, it is going to definitely fall down. It is not going to go up again. Okay, that is all because of gravitational pull. The gravitational pull of the earth is going to pull all the objects or all the masses present on the earth towards itself. Okay, this is much clearer. I repeat it again. Every substance or every mass present on the earth's surface is going to be pulled towards the earth because of the gravitational force of the earth. Now, you need to know that all the masses present on the earth also exert a gravitational pull between them. For example, the blackboard and me. We two are different masses, or else you and your friend sitting in the classroom. But are you people exerting gravitational force and pulling each other towards itself? No, because it is much lesser than the Earth's gravity. The Earth's gravity is more dominating when compared to the gravitational force between any two masses present on the Earth's surface. Okay, so once you read the para, you will understand. Let me repeat it again. It is basically, all the substances present on the earth are going to be pulled towards the earth because of the earth's gravitational force. Apart from this, you need to know that all the masses present on the earth also exert a gravitational force between them. Okay, like you and me and the so me and the blackboard also for exert or exhibit gravitational force towards each other, but we are not exhibiting the gravitational pull. That is, you can't see the blackboard falling on me, of course. You understand that point? That is because the gravitational force or the gravitational pull between us is much lesser than the Earth's gravitational pull. Okay, if I remove the board, it is not going to fall on me, it is going to fall down because the Earth's gravitational force is much stronger than my gravitational force. That happens with everybody. Okay, hopefully you understand all these 3 points over here. So magnetic force, unlike poles attract, like poles repel. Electrostatic force developed because of static electricity. Examples: the balloon rubbed with the paper, the comb rubbed on dry hair, or comb brushed on dry hair, and the blanket while you're removing the blanket on winter mornings. And the third one, gravitational force, the most easiest one. Like every substance on the earth's surface is going to exhibit gravitational pull because of the earth's gravity. Okay, it is going to be pulled towards the earth. Yes. So the three kinds of field forces that we studied were magnetic force, electrostatic force, and gravitational force. So here we have a very simple activity to visualize magnetic field and understand the concept of magnetic field or magnetic region. Okay, so we are on page number 5 for your convenience. So here we are going to take a big white sheet of paper and I am going to place a magnet on it. Okay, the magnet has two poles, north and south. What do I do now? I place some iron filings. Okay, I place some iron filings on my white sheet of paper. Okay, once I place the iron filings on the white sheet of paper, after some time I'm going to tap, okay, wherever I place the white sheet of paper. For example, if I place the white sheet of paper on a table, okay, and on that setup I have also placed a magnet and I've sprinkled some iron filings. Now after some time I tap on the table so that the iron filings have a certain pattern, okay, and I will start noticing that they are forming a certain pattern. Okay, why do you think they are forming a certain pattern? Why do you think that I see too many iron filings near the poles and very less near the central portion of the magnet? Okay, what do you think might be the answer over here? Why don't I see the iron filing somewhere in the corner of the table or somewhere else where I don't see them crowded anywhere else apart from the poles? Okay, let's recall again. So what have we done? We have taken a white sheet of paper, placed on a table. I have placed one magnet with both the poles, north and south. Of course, every magnet is going to have poles. So now I place the magnet in the center of the white paper and I've sprinkled some iron filings on the white sheet of paper. I tap on the table and I see that the iron filings are crowding around the poles and the crowding around the magnet and forming a certain pattern. So you will observe that too many iron filings crowd around the poles of the magnet, okay, and they also have a formation from one pole to the other pole. Fine. the region depicted by the region depicted by these iron filings is called as magnetic field of the magnet. This magnetic field is present around the magnet. Okay, for example, I have another magnet. I place the magnet somewhere over here and with the opposite pole facing facing the south pole. For example, the north pole of the second magnet facing the south pole over here. Okay, I have the north pole facing the South Pole. You will observe that that particular magnet is getting attracted towards the South Pole. Okay, I take away the magnet and I place it somewhere away. Place it somewhere away from the setup. I will see that that particular magnet does not get attracted to my first magnet over here because that magnet is placed outside the magnetic field. Okay, for magnetic attraction to happen, the magnetic materials should be placed in the magnetic field of the magnet. And how do you identify or visualize the magnetic field? Do you see the pattern formed by iron filings over here? This pattern formed by iron filings over here is depicting the magnetic region or magnetic field. So if I place any magnetic material inside this pattern, it is going to get attracted to the magnet. If I place any material outside the magnetic field, it won't get attracted to the magnet. So do you understand now? The region around the magnet is called as magnetic field. How do I visualize magnetic field over here? With the help of iron filings. They are forming certain patterns. Where are they most crowded? They are most crowded near the poles because the poles have the strongest magnetic polarity in them. Now we are going to discuss about the next topic over here. It is contact force. Okay, earlier we have discussed about the types of field forces. Now we will discuss about the types of contact forces. The most prominent one is the muscular force. So by the word muscular, what do you understand over here? This means I'm going to use the muscles to perform the task. Do you understand now? So whenever you are going to use your muscles to push or pull an object so that you perform the task completely, the force exerted by you is called as muscular force. For example, you know, picking up a suitcase, picking up a suitcase, lifting a flower pot, picking up your school bag, digging the bore well, or cycling, running, exercising, cycling, lifting up dumbbells. All these require your muscular force to be performed. So they come under contact forces. You cannot perform the task without not being in contact with them. For example, when I want to write on the board, I need to touch the marker. I can't order the marker to just keep writing on the board. Okay, that would be magic then. So now here, as the examples I've mentioned, picking up a suitcase, I'm holding the suitcase now. I'm holding the handle. Only then I'm able to use my muscular force. Lifting up a flower pot from my garden. So I need to use my hands and lift up the flower pot. Exercising on a treadmill. I need to jog on the treadmill. So my feet needs to be in contact with the treadmill. So in all these tasks, the muscles of my body are being used. And I'm also in contact with that particular object to perform the task. So the force exerted by the muscles to perform the task is called as a muscular force. So we have think and discuss over here in this page and the previous page. The think and discuss portion will be dealt in the end of the chapter. All the think and discuss portions, I will deal with them together. So I would encourage you to also look into it and try answering it on your own, because it is pretty easy. But I will definitely do it for you at the end of the lesson. Okay.